Solving absolute values and inequalities. Absolute value. The algebraic definition of absolute value is that the absolute value of x denoted by the absolute value of x is given by the following. If x is greater than or equal to 0, then the absolute value of x is x. If x is less than 0, then the absolute value of x is negative x. The geometric definition states that the absolute value of x is the distance from x to 0 on the number line. Definition of absolute value. The absolute value of a negative number is its opposite, while the absolute value of a non-negative number is itself. The absolute value of a number is the distance from its number to 0 on the number line. And if a is greater than 0 and the absolute value of x is a, then x equals a or x equals negative a. The first example states to solve 2x, the absolute value of 2x plus 3 is equal to 4. Graph the solution on a number line. To solve the problem, you will have to state two equations. 2x plus 3 is equal to positive 4, and 2x plus 3 is equal to negative 4. To solve the left equation, you will have to minus 3 on both sides, which is 2x equals to 1, and x would equal to 0.5. For the right equation, minus 3 on both sides, which you get 2x is equal to negative 7, and x would equal to negative 7 over 2 or negative 3.5. To graph the solution on another line, you look at the number line and find 0.5, which is around here, and negative 7 over 2 or negative 3.5, which is around here. The next problem states to solve the absolute value of x minus 3 is equal to 3x plus 5. Check your solution. To solve this problem, you have to state the equations x minus 3 is equal to 3x plus 5 and x minus 3 is equal to negative 3x plus 5 in parentheses. The left equation, you have to add 3 on both sides, which will be negative 2x equals to 8, which x would equal to negative 4. For the right, you distribute the negative, which is negative x minus 3 would equal to negative 3x minus 5, which would simplify into 4x equals negative 2, and x would equal to negative 1/2, or negative 0.5. To check the solutions, you would plug the possible answers into the solution. So when you plug negative 4 back in, it will be negative 4 minus 3, absolute value, equal to 3 times negative 4 plus 5. The absolute value of negative 7 will be equal to negative 7, which means the first solution is false. It's an extraneous solution. For the right equation, you plug negative 0.5 back into the equation, which will be the absolute value of negative 0.5 minus 3 will equal to 3 times negative 0.5 plus 5. And the absolute value of negative 3.5 would equal to 3.5, which means that negative 0.5 or 1/2 would be the solution for this problem. For absolute value inequalities, shows that if a is greater than 0 and the absolute value of x is less than a, then x would be greater than -a and x would be less than a. If a is greater than 0 and the absolute value of x is greater than a, then x would be less than -a or x would be greater than a. You can write similar statements for the absolute value of x is less than and or equal to a, and the absolute value of x is greater than or equal to a. The next problem says to solve the absolute value of 5 minus 3x is less than 9. Graph the solution on a number line. First, you would list the two equations. 5 minus 3x is less than 9, and 5 minus 3x is greater than -9. To solve for the left equation, you would minus 5 on both sides, which would be -3x is less than 4, and then divide by -3, but remember to change the sign when you divide by a negative number, which would be x is greater than -1 and 1/3. For the right equation, you would minus 5 on both sides, which you get -3x is greater than -14, and then divide by -3, change the sign, which will you get x is less than 4 and 2/3. To graph the solution on a number line, you would first find the points on the number line, -1 and 1/3, which would be around here. Remember that it's going to be an open circle because it does not, -1 and 1/3, it does not fit into the equation. And for 4 and 2/3, it will be around here, and which would also be a open circle. And when you check the answer choices, you will find that the equation would now say that only the numbers between -1 and 1/3 and 4 and 2/3 would work in the equation. Therefore, you would color the line between -1 and 1/3 and 4 and 2/3 to represent that these numbers would work in the equation. For more practice, we are going to solve the absolute value of 5 minus 3x is greater than 9 and graph the solution on a number line. To solve this equation, we need to list the two other equations, would be 5 minus 3x is greater than 9 and 5 minus 3x is less than -9. To simplify the left equation with minus 5 on both sides, which we get -3x is greater than 4, and divide by -3 with x would be less than -1 and 1/3. For the right equation, we are going to minus 5 on both sides, which you get -3x is less than -14, and divide by -3, which you would get x is greater than 4 and 2/3. Now we have the 2 points. We are going to graph this on a number line. To find -1 and 1/3, which would be around here, and 4 and 2/3, which would be around here. Remember that these two are open circles because these numbers does not fit in the equation, but the number is less or greater than it. Then you will see that all numbers that is less than -1 and 1/3 will work, which you would color the left side of -1 and 1/3, and then all the numbers greater than 4 and 2/3 would work in the equation. Which you would color the right side that is greater than 4 and 2/3.